Some functions are so small that writing a whole def block for them feels like overkill. For those, Python gives us a shortcut called the Lambda. By the end of this episode, you'll know exactly what a Lambda is, how it compares to a normal function, the different shapes it can take, and, just as importantly, when you should reach for a regular def instead. A Lambda is an anonymous function. Anonymous simply means it has no name of its own. Instead of a full def block spread over several lines, it's written inline in a single line, right where you need it. Let's walk through the anatomy of a Lambda, piece by piece. It starts with the keyword Lambda, then the parameter x, then a colon to close the header. Now we feed it a value. The number 5 arrives as x, and the expression x times 2 hands back 10. Notice we never wrote the word return. With a Lambda, returning the expression is automatic. Let's store one in a variable so we can reuse it. Double is a Lambda that takes x and gives back x times 2. The moment it's sitting in a variable, it behaves like any other function you've written. You call it with parentheses, and it returns a value. Lambda x starts the function, declaring a single parameter called x. Everything after the colon is the body, the single expression whose value comes back. And we call it exactly like a normal function, passing 5 in. Run it. 5 doubles to 10, and 9 doubles to 18. It really is a complete function under the hood. It's just written in a compact, throwaway style. So how does that compare to a regular function? They do the exact same job. The Lambda is just shorter. Understanding where they overlap and where they don't is the key to using Lambdas well. Triple is a normal def with an indented body and an explicit return. Quad is a Lambda doing the same style of work. Placed side by side, you can see they're two ways of expressing the same idea. One verbose and named, one compact and inline. The classic way. A def header, an indented body, and a return statement. The Lambda compresses that entire idea onto a single line. 3 tripled is 9, and 3 times 4 is 12. Identical behavior. The only real difference is how much you had to type. A Lambda doesn't even need arguments. Leave the space before the colon empty, and you get a zero-argument function. You still call it with empty parentheses. The parentheses are what actually run it. Nothing sits between Lambda and the colon, so this takes no arguments at all. Empty parentheses are still required to actually call it and get the string. It hands back the greeting. A function with no inputs is still very much a function. Real quick, if this is clicking for you, tap that like button. It genuinely helps other beginners find the series. And hit subscribe, so the next episode lands right in your feed. Lambdas can also take more than one argument. You just separate them with commas, exactly like a normal function's parameter list. Everything after the colon can use all of them. 2 parameters here, a and b, then the expression that adds them. We pass both values across when we call it. 3 plus 4 is 7, and 10 plus 5 is 15. Because the body is a single expression, you can put a conditional inside it. That's the ternary you met earlier in the course. This is one of the spots where a Lambda genuinely reads better than a full function. Sign uses a ternary right in its body. If n is above 0, it returns the word positive. Otherwise, it returns the other label. A whole little decision function, captured in one clean line. The ternary lives inside the Lambda body. Value if condition, else the other value. Call it with a positive number. And again with a negative one. 7 is positive, -3 is 0 or below. All decided inside a single expression. Now the important caution. A Lambda can only hold a single expression. The moment you need several steps, a loop, or multiple lines of logic, A Lambda simply can't do it. And even when it can, a normal def is often clearer. Short and throw away is the sweet spot. Here's a Lambda actually pulling its weight. We define a tiny square function once, then reuse it on every number from 1 to 4 inside the loop. Small, named, and reused. That's a good Lambda. A one-line squaring function defined once and called fresh on every pass through the loop. 1 and 1, 2 and 4, 3 and 9, 4 and 16. If your logic ever grows past a single expression, that's your signal to switch to a normal def. One last thing that trips people up. A Lambda holds a single expression, not statements. You can't put a print, an assignment, or a full if block inside one. If you catch yourself wanting to, that's your cue to write a normal def. Here's a handy one. A Lambda that builds a label from a name and a score. It takes 2 arguments, converts the number to text, and joins everything into one string. Small, focused, reusable. 2 parameters, then 1 expression that stitches them together. SDR turns the number into text so we can join it onto the name. Ada:95, Alan:88. A tidy little formatter in a single line. Before you go, the entire Python 0 to Pro playlist is linked in the description. Bookmark it and binge the rest in order. Lambdas are perfect for the small stuff and a warning sign when they grow too big. Next up, we treat functions themselves as values you can store, pass, and return.